Welcome to Machine Learning Frontiers, insights from the arXiv preprint server cs.LG. In this episode, we spotlight 72 research papers published on August 7, 2025, covering technical advances and human stories from the forefront of machine learning. Today's highlight is the paper by Wu and colleagues on dynamic fine-tuning. Join us as we decode the future of artificial intelligence. Imagine a world where the largest language models run effortlessly on everyday devices, even your toaster, thanks to revolutionary compression techniques. Models can now be reduced to just 2 bits per parameter, preserving or even surpassing their initial accuracy. Once considered impossible, this breakthrough by Wang and collaborators is now a reality. Widespread deployment of sophisticated AI on any device is within reach, raising important questions about the future capabilities and accessibility of artificial intelligence. To set the stage, consider cs.LG as the primary arena where machine learning innovations are forged. The 72 new papers featured today represent a vibrant, dynamic ecosystem, spanning algorithms, fairness, security, and clinical applications. This episode guides you through these advances, providing not only updates on the latest research, but also insight into their significance for the field and for society. The cs.LG category, standing for Computer Science, Learning, and Generalization, serves as the bustling center of artificial intelligence research. Here, theoretical frameworks and practical solutions are developed side by side, ranging from algorithmic innovation to questions of fairness and privacy. This interdisciplinary hub brings together computer scientists, statisticians, engineers, and neuroscientists, all collaborating to shape the future of technology in domains such as autonomous driving, healthcare, and music recommendation. The first major theme is the optimization of large language models through efficient fine-tuning. Researchers, including Wang and colleagues, are achieving significant compression of these models without sacrificing performance. The Fairy +-I framework can shrink massive models into compact forms, enabling deployment on smartphones, edge devices, and even basic appliances. This bit-efficient approach marks a new era of accessibility, likened to folding a king-sized comforter into a lunchbox, making advanced AI available anywhere. The next research focus addresses trust, security, and fairness within AI systems. Ensuring safety, unbiased decision-making, and robustness against adversarial attacks is paramount. Defenses against backdoor attacks, as explored by Constantine and collaborators, and methods for detecting bias in clinical survival models, as shown by Genselme's team, represent critical progress. These efforts are reminiscent of city planners who designed strong defenses and equitable infrastructure, ensuring that algorithmic bias, where models inadvertently learn unfair patterns, is rigorously identified and mitigated. A third central theme combines federated, decentralized, and explainable AI. In federated learning, devices collaborate to share knowledge while maintaining data privacy. Decentralized frameworks like Lightyear, introduced by Constantine and colleagues, allow for robust peer-to-peer model updates. Simultaneously, advances in explainability, such as automatic rule generation for trajectory prediction by Zhao's team, make AI's decision-making more transparent. Akin to a clearly marked street map, this collaborative landscape can be visualized as a potluck dinner, where the recipes remain private, but the collective meal benefits all participants. Several key findings stand out from this body of work. Wang and collaborators demonstrated that 2-bit language models can outperform those with full precision parameters, defying long-standing assumptions. Wu's dynamic fine-tuning approach enhances model generalization. Constantine's peer-to-peer federated learning proves robust even in disruptive conditions. Zhao's evolutionary heuristics surpass traditional deep networks in trajectory prediction. Genselme's research redefines fairness standards in clinical AI modeling by highlighting the impact of competing risks. Each discovery reshapes current understanding and practice. Delving into the paper of the day by Wu and colleagues, the initial motivation was to understand why supervised fine-tuning often results in models that excel on training tasks but underperform in real-world, open-ended situations. Traditional training techniques, such as treating all predicted words as equally important, lead to overfitting and limit a model's ability to generalize. Wu and team questioned whether a minor adjustment could bridge this gap. Aspiring to build models capable of thinking beyond their initial training, a step toward broader generalization. Dynamic fine-tuning, or DFT, as introduced by Wu and colleagues, implements a single-line modification with substantial impact. By scaling the training reward according to the model's own uncertainty, DFT encourages greater focus on challenging predictions and less on those already well-mastered. This technique improves performance on out-of-distribution data, similar to handling unforeseen questions on a pop quiz. In several benchmarks, DFT outperformed more complex reinforcement learning methods by replacing standard cross-entropy loss with an adaptive reward mechanism. The human story behind Wu's dynamic fine-tuning illustrates the profound effects of incremental innovation. The pivotal insight was recognizing model uncertainty as an untapped signal during training. DFT's stability, ease of implementation, and lack of additional computational requirements facilitated its rapid adoption with the codebase released as open source. This work exemplifies how deep theoretical understanding can lead to practical advances, reinforcing the value of small yet insightful modifications. Looking to the future, the field of machine learning is likened to a thriving, interconnected forest. Growth is no longer measured solely by model scale, but by efficiency, interpretability, and resilience. Decentralized learning frameworks resemble strong, flexible vines that can withstand perturbations. Explainable AI lays the foundation for trust, while fairness initiatives ensure equitable benefits. Anticipated developments include real-time model adaptation and collaborative human-AI problem-solving, much like a diverse forest flourishing through interconnected roots and branches. In summary, the cs.LG research community is driving rapid, responsible advancements in artificial intelligence. Efficiency improvements, such as those by Wang and colleagues, and interpretability breakthroughs, like Wu's dynamic fine-tuning, are transforming the future landscape. Minor theoretical insights are producing significant real-world impacts, while fairness and privacy considerations are increasingly central. The call to action is clear. Explore the literature, engage in thoughtful discussion, and remain curious, as the next major breakthrough may emerge from a simple idea or a fresh perspective. This synthesis and review process combines the strengths of AI tools and human expertise. Summaries were generated using GPT 4.1 by OpenAI and reviewed by domain experts for accuracy. Text-to-speech narration is powered by OpenAI, while image suggestions are provided by Google. Human oversight ensures clarity and relevance, though minor oversights may persist. Comprehensive references for all cited papers are included, reflecting a collaborative effort between artificial intelligence and human reviewers to deliver high-quality, accessible insights. Subscribe to AI Frontiers for weekly deep dives into the latest AI research. Join a community passionate about the progress and impact of machine learning. Stay informed about emerging breakthroughs and trends by following the AI Frontiers channel. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.